Hello students, welcome to another video of Vedantu Karnataka. This is Catherine and I am your physics master teacher. So today you might have already seen the thumbnail. So all of those who are moving to class 11, you might have already started with your class 11. So here is a small class with some quick tips and tricks and some basics that you need to know in your class 11. So come along with me for this session and I will teach you all the tricks and tips you need for class 11. So this will also be helpful for your NEET exam, JEE and all as well. Okay, so let's start. Yes. So first thing is maths, quadratic equations. But ma'am, this is a math lesson or a physics lesson? This is a physics lesson, and for any physics lesson, math is very important. So the most important basics that you need to know is for quadratic equations. Okay, so let's see what a quadratic equation is. Quadratic equation is an equation in the form of x squared plus, okay, I will write it down. Which color? Yellow? Yeah. Ax square plus bx plus c is equal to 0. Any equation of this form is called a quadratic equation. So a could be a number, b could be another number, c could be another number. If you look at our question, what are the values? A is 1, b is 9 and c is 20. Now, if there are negative values, you should put negative. For example, if the question is x square minus 9x, then your b would be minus 9. Okay? Now, these kinds of questions can be solved in two different methods. The first one is called the splitting method. These are the most common methods. Okay? So, let's look at the splitting method. So, it's called the very famous splitting method. Okay, so what is splitting method? So you have to see what all numbers multiply to give you 20 and add to give you 9. For example, here our numbers are 20 and 9. So we know that 4 into 5 can give you 20. Okay, 4 plus 5 can give you 9 as well. Since the question is x square plus 9x plus 20. Okay, so how will we split it? We can write it as x square plus, instead of 9x, you write it as 4x. Instead of, 9x is 4x plus 5x plus 20 is equal to 0. Now you take the common term. So x is common for x square plus 4x. X you take outside. What remains? X plus 4 plus 5 is common in 5x plus 20, x plus 4. Now we have two common terms, x plus 4, x plus 4. So when you equate them, this becomes x plus 5 into x plus 4 equals 0. So what would it become? Individually, if you write it down, you will get x plus 5 equals 0, x plus 4 equals 0. So x is minus 4 and minus 5. Minus 4 and minus 5. Okay, this is one way of doing it. Now there's another way of doing it, which is by taking the formula for quadratic equation. Okay, let's look at the method 2. Okay, so method 2 is by using the formula x is equal to minus b plus or minus root of b square minus 4ac by 2 into a. Okay, now what was our question? X square plus 9x plus 20. So let's just write that down here. X square plus 9x plus 20 is equal to 0. So now let's solve it. So x would be equal to, what will our minus b be? So a is 1, b is 9, c is 20. Yes, or if you agree with me. So what would a be equal, x be equal to? Minus b, which is minus 9 plus or minus square root of b square is 9 square. 9 square minus 4 into a is 1, c is 20. The whole divided by 2a. So 2 into, how much is a? 1. So 2 into 1. Now solving the math, I will get minus 9 plus or minus 9 square is 81 minus 4 into 20 is 80. 80 divided by 2, which is equal to minus 9 plus or minus 81 minus 80 is 1. Square root of 1 is 1. 1 by 2. So this will be what all? Minus 9. What happened? This pen is misbehaving. Sorry, students. This will be minus 9 minus 1 by 2 and minus 9 plus 1 by 2. And what are those? Minus 9 minus 1 by 2 is how much? Minus 10 by 2. Minus 9 plus 1 by 2 is minus 8 by 2. So what are the answers going to be? I don't know if my head is blocking what I'm writing. So I'm sorry. Minus 8 by 2 and minus 10 by 2, which is how much? Minus 4 and minus 5. Same answers. So the same quadratic equation we've used in 2 steps. Okay? Is this clear to all of you? I hope this is clear to all of you. So this is the first thing that you need to know in physics to solve quadratic equations. And you should be fast. Okay? I've just done it slowly because I've done all the steps. Now I'll show you some tricks to solve some quadratic equations. So you can actually guess some quadratic equations. How will you do that? So let's say you have some quadratic equation of the form. Let's say, what should we put it? A times A plus 1. Okay? And I tell you it's equal to 6. How will you find out A? So we know that 3 into 2 is 6. Yeah. So 3 is 2 plus 1. So shouldn't A be equal to 2 such that 2 into 2 plus 1 is 6. 2 into 3 is 6. So if you get a question in the form of A into A plus 1 equals 6, then the answer is definitely 2. Now A into A plus 1 can also be written as A square plus A minus 6 is equal to 0. Is the same? Yes? Okay. So this is 1. Now another question. Let's say B times B plus 2 is equal to 24. Okay. Now I want you all to pause the video. Quickly solve it. How much would B be? Okay. Yes. Have you all paused the video and solved it? I hope by now you would have solved it. Yes. So what is the answer? We all know 6 4s are 24 and 4 plus 2 is 6. So B should be equal to 6 or 4? 4. Such that 4 into 4 plus 2 is 24. Next, let's say you have T. My pen is not behaving well. What alphabet should we put here? Let's put it in order. Let's put C. Okay. C into C plus 1. Let's say in this case it's equal to 90. Okay. So what will you do? So okay, again, pause the video, solve it. Okay, I hope you've solved it. So 9 into 10 is 90. 9 plus 1 is 10. So C is definitely 9. Okay, so these are some tricks that you can use. And there are some more questions. Another question, let's say, what should we put? Let's say D plus 1. Okay, and D plus 2 is equal to 12. How will you solve it? So D plus 1 and D plus 2 should be equal to 12. So we know that 3 times 4 is 12. So something plus 1 and something plus 2. It should end up in 3 into 4. So what should it be? 2. 2 plus 1 is 3. 2 plus 2 is 4. So D should be 2. So you get 3 into 4 is equal to 12. Okay? Is this clear? So these are some small tricks to solve quadratic equations. Next important thing that you need to know in your 11th and 12th in terms of entrance point of view is multiplication table of all numbers from 1 to 20, or if you can learn to 25, well and good. You also need to learn squares from 1 to 20, cubes also from 1 to 20. If you can learn all this from 20 till 25, it's good. Okay? And some basics of logarithm also you need to know, the log of 2, log of 3 and all of that. Okay? These things if you can memorize before now itself, it's going to help you a lot throughout your 11th and 12th. Okay? Yes. Next is directions. Okay. So east, west, north, south, you have to know very well. So what are the directions? Okay. So for this, what you can do is you can stand or sit. Okay. And north is always in the upward direction. South is always in the downward direction. East is towards your right. West is towards your left. Okay. So if I'm standing, this is my north, south, east and west. Okay. So now sometimes there are some questions. For example, imagine there's a question. They say there's someone, okay, some person, he starts from a point and then let's say he moves 10 meters in the south. Then let's say he moves 10 meters in the west. And then he might move 10 meters or say, 10 meters in the south. Then he moves 10 meters in the east. Now the question is to find his displacement. So in questions like this, you need to know directions very well. So what you do is you draw an axis, you take 0, 0, okay? And look at the directions in which he moves. So the first thing he moves is 10 meters in the south, which is down. So he moves down, okay? 10 meters. And then he moves 10 meters in the west, which means he moves this way. Not like a heartbeat, but he moves straight. Okay, students? So he moves 10 meters in the west. And then he moved again. Let's make this north so we can cover all directions. So he moved 10 meters north. So he moved this way again. And then he moved 10 meters east. So he moved this way again. So which means after all his movement, he came back to the initial position, which is this point. He came back to its initial position. So now the total distance he moved will be 10 plus 10 plus 10 plus 10. The total displacement will be the shortest path he took, which is basically 0. Because he hasn't moved. According to displacement, he is where he started. So his displacement is 0. Now for some of you might be wondering what is displacement and distance, what the difference is. Distance is the total distance a person travels. Displacement is the shortest possible path a person can take. Okay, I can give you another example. Let's say you move from A and you go all the way till B. So the total path you cover is your distance. Displacement is the shortest path you can take, which is this straight line. Okay. So that's the difference between distance and displacement. So to do questions like this, you need a good sense of direction. You need to know which is your north, which is your south, which is your east, and which is your west, which you know now. Okay, good. Yes, let's proceed. Okay, now we look at physical quantities. What are physical quantities? So physical quantities are something that you can measure. So you say, ma'am, he's very angry at me. Can you tell how much angry he is? You might be able to tell from his face or from his actions, but can you measure how much angry he is? You cannot. That's because anger, happiness, love, sadness, all those are not physical quantities. Physical quantities are quantities that can be measured, like speed, temperature, length, mass. All those kinds of quantities are called physical quantities. Okay? Is that clear? Good. Okay. Now there are two kinds of physical quantities. Okay. So if you have a physical quantity, if you have a physical quantity, you can divide it into two: scalar quantities and vector quantities. What are scalar quantities? What are vector quantities? So scalar quantities are quantities which have only magnitude. What do you mean by magnitude? Which have only value. Okay. For example, I say he ran with a speed of 5 meters per second. Okay, which is too much. So if I say that, that means he ran with that value of speed. I'm not talking about which direction he ran in. I'm only talking about the value which is 5. So that kind of a quantity is called a scalar quantity, where only the value or the magnitude matters. Okay. Now, a vector quantity on the other hand is a quantity which has a magnitude and a direction. Okay. For example, let's say I say he ran 5 meters per second to the north. Now this becomes a vector quantity because I have talked about his magnitude and his direction. The magnitude was 5, the direction is north. So when both of these are equally important, then that quantity becomes a vector quantity. When only magnitude is important, then that quantity becomes a scalar quantity. Are you getting it? Now, another example of a scalar quantity is distance. So imagine you walk from your house to your school. So in which direction you walk does not matter. Only how much length you walk, how much path you cover. That makes your total distance. Let's say it's 10 kilometers. So whichever direction it is, from your house to your school, it's 10 kilometers. You don't have to specify direction there. It's still valid. When you say 10, it's 10. So that is a scalar quantity. But when you talk about displacement, you have to say it is 10 kilometers in the northeast direction or the southwest direction or the east direction, some direction. Only then displacement becomes valid. So distance is a scalar, displacement is a vector. Similarly, I can give you two other quantities, speed and velocity. The example I just mentioned. So when you're running, you only look at the value. That's when it becomes the speed. When you're running, you look at the value and the direction. That's when it becomes velocity. So one is a scalar, one is a vector. So basically, in simple terms, you can say velocity is speed with direction. But there's a lot of physics to it, but simply in simple terms, you can say that. Okay. So there's an example given here. 25 kilometer per hour is a scalar. But 25 kilometers per hour to the north becomes a vector. Okay. Now, other than scalars and vector, there's also one more kind of quantity which is a little advanced. It's called a tensor. So, tensors are quantities that have multiple directions. That at this level, you don't have to learn. Okay. So, scalars, vectors and tensors. Scalars, only magnitude, no direction. Vectors, magnitude and direction. Tensors, multiple direction. Okay. Good. Shall we move on? Yes. Okay. Okay, now I can give you a question. Let's say a bus moves, okay? A bus moves with a 10 meters per second speed. Is this a scalar or a vector? Since I mentioned speed, it's obviously a scalar. If I don't say speed, a bus moves with 10 meters per second. Is this a scalar or a vector? Quickly tell me the answer, students. Yes, you are right. It is a scalar. Why? Because there is no direction. Now, in the same question, I modify and I say a bus moves with 10 meters per second. Which color? Towards north. Now, what happens? Now, this becomes a yes, you are right. It becomes a vector. Okay. So this is how scalars and vectors are different. Okay. Any doubts here? So it has scalar has no direction. Vector has direction. Another example of vector I can say is temperature. So when you go to a doctor and you have fever, the doctor puts a thermometer and says your temperature is 28 degree or 29 degree. He does not say 29 degree inside the body or outside the body, nothing. It's just the value that matters there. Such quantities are scalar. Did I say vector? No, right? Temperature is a scalar quantity. Okay? Yes, let's move on. Next two terms that we're going to learn are rest and motion. So what is rest? I am sitting. So I am at rest. You might be sitting and watching, or you might be lying down on bed and watching. So you are also at rest. Now, if you're walking and watching on your phone, you are in motion. Simple, right? Rest is when you're not moving. Motion is when you are moving. But relatively, this can be said in a different way. Imagine you're going in a bus. Okay, the bus driver is sitting, you are sitting. If you look at the bus driver and the bus driver looks at you, both of you are at rest because you are both sitting inside the bus. Now, a person in the bus stop is standing outside. When he looks at you, both of you are moving with respect to the bus, right? So, rest and motion are relative terms, which means that it depends on from where you're looking. So, if you're looking from inside the bus, both you and the bus driver, both of you are at rest. But if you are looking from outside, both of you are in motion. So it also depends on from where you are looking. Okay? Yes? Okay. So that's rest and motion. So the main concept here is that you always have to have a frame of reference. So you can say, we are at rest with respect to the bus. Or a person outside can say, those people in the bus are moving with respect to me standing stationary. So with a certain frame of reference, you have to define rest and motion. Okay? Good? Yes? If it's a yes, can you all put some thumbs up in the chat? Okay. Next is speed and velocity and their conversions. So what is speed? What is velocity? You already know now. Speed is just, you can see the speedometer. On the speedometer, it's 300. Okay. Let's say it's 300. Direction does not matter because it's speed. But 300 in the forward direction will make it velocity. Okay. I hope you get the difference now. But now you have to convert. Okay, so there are two units for speed and velocity. There's meter per second and then there is kilometers per hour. Now, conversion of meter per second to kilometer per hour is something very important, not only in your PU perspective or your 11th and 12th perspective, but also in terms of entrance exams as well. Okay, so let's say you have to convert 1 kilometer per hour to meters per second. How will you do that? 1 kilometer is how many meters? 1000 meters. 1 hour is how many seconds? 1 hour is 60 minutes. 60 minutes is 60 into 60 seconds. So 60 into 60 is 3600 seconds. Okay. Now if you do the math, if you divide it, what will you get? You will get 5 by 18 meters per second. So 1 kilometers per hour is 5 by 18 meters per second. Okay. Now, one trick for you to know this is, I already told you should learn the multiplication table of 1 to 20 or 25. Now, if you have done that homework well, then this is very easy. Okay, so what I have here is the multiplication table of 5. What I have here is a multiplication table of 18. Okay. Now, let's say the question is to find out 18 kilometers per hour to how many meters per second? Okay, so look at 18 kilometers per hour is 5 meters per second. So this is kilometers per hour. This is meter per second. Now let's say the question is 144. Okay, so 144 kilometers per hour is how many meters per second? So 18 into 8 is 144. So 5 into 8 is 40. So it's going to be 40 meters per second. Okay, do you understand that? So if you want to find out 180, 18 into 10 is 180. So 5 into 10 is 50. So 50 meters per second. So this is how it is, the corresponding values. Okay. So if it is 54 kilometers per hour, 3 into 18 is 54. So 3 into 5 is 15. So the answer will be 15. Okay. Do you understand that? Clear? Not clear? Yes? No? Okay. So, yeah. So if you want to find out 72 kilometers per hour, 4 into 18 is 72. So 4 into 5 is 20. So 72 kilometers per hour is 20 meters per second. So if you know these tables, within seconds you can write this. You don't have to multiply into 5, 18 and all. Okay. So this is a small trick for all my students. Okay. Next are equations of motions and acceleration and all of that. So let's look at the basic formula for acceleration first, and then we can solve these questions. So first you need to know what is acceleration. You might have learned that, but if there's one student out there who does not know what acceleration is, then this is for you. Okay, what is acceleration? Acceleration is when you are driving, okay, and let's say you are going with a speed of 30 meters per second, okay. After 10 minutes, you're pressing the accelerator. Now the car is going at 60 meters per second. Now again after 10 minutes, the car is going at 90 meters per second. So this just goes on. So what happens here? The speed is increasing. Yeah. The speed is increasing at regular intervals of time. So you are basically accelerating. Okay. So when the speed is increasing, you are accelerating. Okay. Now, how will you find out the value of acceleration? Acceleration is change in velocity by time. Okay. Change in velocity by time. So, will it be visible? No, not really. Okay, I will write it on a different sheet. Just a second, students. Yeah. Acceleration is change in velocity by time. So what is the value of change in velocity? Change in velocity is initial velocity minus final velocity by time. So in our case, it was 60, 30 and 10. Okay. So final velocity is 60, initial velocity 30. This is 10. So what will it be? 60 minus 30 by 10. Yes. So this was going to be 30 by 10, which is 3 meters per second square is your acceleration in the first 10 minutes. Now in the second 10 minutes, then I take initial to be 60, final to be 90. Okay. So acceleration is again v minus u by t. So 90 is your final. So this would become 90 final, 60 initial by 10. This is again 30 by 10, which is 3 meters per second square. Okay. So what can you see here? You might all be confused, ma'am, what is happening. Okay. It's very simple. See, the speed is continuously increasing and the car is accelerating. But the car is accelerating uniformly. That means every 10 minutes, the acceleration is 3. So the speed is increasing with a constant value of acceleration, which is 3. Okay? Do you get that? So speed is increasing, car is accelerating with a constant value of 3. Now this is just one case. Now imagine the speed varies from 30. Let's say it goes from 30, then it goes to 100, then it goes to 150. Definitely when you do v minus u by t, you will not get the same answer. Now you can say it is accelerating and the speed is increasing. Acceleration is not uniform. It will just randomly increase. See, 100 minus 30 by 10 is not going to be the same as 150 minus 100 by 10. Okay. So in this case, it is not going to be uniform acceleration. So there are two kinds of acceleration, uniform and non-uniform acceleration. Acceleration is when the speed is changing. The speed could be increasing or decreasing. If it's decreasing, then it's called deceleration. Okay? Yes? Okay. Now, here are some example questions. You can definitely work them out. We will just solve one. So, let's change color. Yeah. Find the acceleration of a truck if its speed increases from 30 meters per second to 90 in 15 seconds. So, what happens? 90, it goes to 30 in 15 seconds. So you can just do 90 minus 30 by 50. Simple as that. Okay. Similarly, you can try to solve all the other questions and let me know the answers in the comment box. Okay? Yes. So, from this equation that you just learned, A is equal to V minus U by T, I can derive an equation of motion. So, what I will do, I will cross multiply T. So, I will write it as AT is equal to V minus U. From here, I will write it as, my pen misbehaves sometimes. I'm sorry for that. Yes. Yeah, I will write it as AT plus U is equal to V. So that is one equation of motion. V is equal to U plus AT. So which means indirectly in all these questions, you used an equation of motion. See, the beauty of physics. The beauty of physics is that sometimes some equations come in different forms. Okay. So the equation that you use for all of these is the first equation of motion, which is V is equal to U plus AT. Okay. Now, in your school, you will learn, derivation with a graph and all of that. But for your entrance point of view, this much is enough. Okay. Yes. Next is motion and speed. So, what is speed? Speed is distance by time. Okay, what? Speed is distance by time. So, then what should velocity be? Velocity should be displacement by time. Okay, so if speed is distance by time, velocity should be displacement by time. Because speed is a scalar, distance is a scalar. Velocity is a vector, displacement is also a vector. Okay. Yes, and then these are the equations of motion. V is equal to U plus AT, we just learned. How did I find that out? I know acceleration is change in velocity by time. From that I easily got it. And there are two more other equations of motions which you can derive easily. Okay? Okay. Next is force, work and power. So what is force? Force is a push or a pull. It's a vector quantity. Okay? So if I, push you, you move. I'm applying a force there, that's why you're moving. But am I really doing work there? Now, if I'm pushing a wall, I'm applying a force on the wall. Continuously for a long time, I'm applying a force. But am I really doing work there? Yes, that's the tricky question. When you're applying a force, you are not always doing work. When you apply a force and whatever is there in front of you, whatever you're applying the force on, if that moves, that is when you are doing work. Okay, so what is the difference? Work is force into distance, or you can say displacement, because direction is important. Okay, so when are you doing work? When you apply a force and something is moving. Okay, now you can also talk about power in terms of work. So the amount of work you do in a certain amount of time determines your power. Some people say they're very powerful because they can finish work quickly, faster than some other people, right? So, let's say, okay, there's an example here. So, Ben finishes his work faster than Anna. Okay, so they both have the same work, but Ben finishes first, Anna finishes second. So, what happened? What does it mean? Ben has a higher power than Anna. Why? Because, okay, there is no extra page, so I will write it here itself. Why? Because power is work done by time. So if both of them have the same work, so let's say they both have the same work to finish, and one finishes in 10 minutes, the other finishes in 20 minutes. So who will have more power? The one that finishes in 10 minutes, the one that finishes in less time. Okay, so that is, next time someone says about power, you can tell them, yes, power is how much work you can do in a certain amount of time. So who is more powerful? Someone who can finish a lot of work in a small amount of time. They are more powerful. Okay? What is work? Work is when you're applying a force and something actually moves. Something happens there. Okay? And what is force? A push or a pull. And it is a vector quantity because the direction in which you apply the force is important, right? See, you want to push your friend. You have to push in the direction in which he falls. Otherwise, if you turn back and push, there's no point. Get it? Okay. Next important concept that's going to be new to you is waves. Okay. So there are two kinds of waves that you will learn mainly here, sound waves and light waves. And you will also learn two new terms, longitudinal waves and transverse waves. So what are longitudinal waves? What are transverse waves? Okay. So let's say, what should I say? So imagine I have a rod here. Okay. And I am standing here. I have a rope in my hand. Okay. So if this, yeah. Let's say I have a rope in my hand and I've tied one end of the rope to this pole. Okay. All of you here, are you able to visualize? So you're standing, you're holding a rope. This rope is tied to a rod. Next thing that you're going to do is, I'm going to move my hand up and down. Okay. So what happens to the rope if I move my hand up and down? What happens? This rope will move like this. The rope will start making waves. Yeah. So you can see the waves are starting from my hand because that is where I'm moving. So the waves are moving in the forward direction. But if you look closely onto the rope, okay, if imagine this is the rope, okay, if the waves are moving, but if I look at the rope, each particle on the rope is going to move up and down, isn't it? Each particle on the rope is going to move up and down, but the whole wave is moving forward. Are you able to understand that? So every particle on the wave is moving up and down, but the whole wave is moving forward. So what is that? That means the direction of propagation of the wave and the direction of propagation of the particles. Okay? So the direction in which the particles move and the direction in which the whole wave moves, they are perpendicular. Which means if one is up and down, the other is left and right. So if particle is left and right, wave is up and down. Such kinds of waves are called as transverse wave, and the most famous example or the common example is your light waves. Okay, so light waves are transverse waves, and I explained what transverse waves are. Now, what are longitudinal waves? So, what are longitudinal waves? These are the two types of waves. Okay, transverse and longitudinal. So, longitudinal waves are, we'll take an example of a spring. Okay, I'm very bad at drawing. Okay, so let's think of a spring. I should have got a spring. I'm really sorry, students. So, let's think of a spring. If I compress the spring moves in which direction? Left to right. Now, each particle in the spring is also moving left to right, isn't it? So, the whole wave is moving left to right. No particle in the spring is moving up and down. Particles in the spring are also moving left to right, which means the whole wave and the particles are moving in the same direction. Yes, do you get that? The particles and the wave are moving in the same direction. They are parallel to each other. So, the particles oscillate in a direction parallel to the direction of the whole wave. Such kinds of waves are called longitudinal waves, and example is sound waves. Now, before talking about all this, I should have told you what a wave is. So, what is a wave? A wave is something that can transfer energy from one point to another. Like, the sunlight. Sunlight gives you energy from the sun to the earth with the help of light rays or light waves. Now, sound waves from a speaker. You're able to hear sound because of the sound waves traveling. So, sound waves travel sound energy. So, waves are just some waves just carry energy from one point to another. So depending on the different kinds of waves, they transfer different kind of energy. Is that clear? Yes. Now, yeah. Before we will go on to all of this, yeah. So that's about waves. Now, under force, work, and power, there is one more term that you should know that's called energy. So, what is energy? See, energy is basically the ability of something to do work. So, in some cases, you can say when work is done, that is the same as energy being transferred. Okay, so you say, okay, that much work is done there, which means he applied some force, some movement happened, work is done. So, when that work was done, there is some energy also being transferred. Okay, so work done is always same as energy transfer. Now, energy is also of two types, kinetic energy and potential energy, which all of you might know. So, not going into complexity of all of that. In simple terms, what is kinetic and potential? Potential energy is the energy of a body at rest. Okay? Imagine I am sitting here. The energy I have is potential energy. But one important factor for potential energy is it changes with height. So if I'm sitting on the ground floor, I'll have a certain value of potential energy. Now imagine I go to the 10th floor. I'll have a different value of potential energy. Why? Because potential energy is mgh. It depends on height. Okay. Now, if as I said, if I'm sitting, I have a potential energy, and then when I start walking, what happens? I am moving. So my potential energy now gets converted into kinetic energy. Kinetic energy is the energy of a moving body, and kinetic energy is half mv square, which means it depends on the speed of the body. Potential energy depends on the height at which the body is. Kinetic energy depends on the speed of the body. Do you get that? So that's energy, work, power. We also looked at waves. Okay, now what else should we do? We looked at sound waves and light waves. Another important thing I can tell you here is sound waves have the speed of approximately 330 to 360, let's say 340 meters per second. But light waves have a speed of 3 into 10 raised to 8 meters per second, which means 3 and 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 3 and 8 zeros. Okay, so 3 into 10 raised to 8 meters per second. For sound waves, it is 340 meters per second. You can look at the difference in speed for both. Yes, so the difference in speed for a sound wave and a light wave. Now, you might have heard the very famous question, why lightning and thunder, they occur at different speeds. You can clearly see because light wave has a very high speed of 3 into 10 raised to 8 meters per second. But sound wave, it has a speed of only 340 meters per second. Okay, so that's why light wave is also used in transferring, a lot of information because it's very fast. You can transfer signals instantly. Okay, next. Next important thing that you need to know is basic trigonometry. That also you need to know for your math in physics, not in your math lesson, but in physics, you need to solve a lot of questions based on sine theta, cos theta, tan theta, and all of that. Okay, so one important thing I can tell you is whenever you have a triangle, your maths teachers might already have taught you, but since I'm teaching you basics, I'll teach you this as well. So let's say you have a triangle. Okay, so in this triangle, there is a 90-degree angle. So the side that's opposite to the 90-degree angle, that is going to be your hypotenuse. Okay. Now, how do I find sine theta? First of all, I need to know which angle I need to take. So for example, look at this. In this figure, I will make this a triangle and I need to find out this angle. Okay. So how do I do that? First thing, I need to identify the hypotenuse. So this is my 90-degree angle. This is definitely my hypotenuse. Otherwise also it looks like a perfect hypotenuse for those of you who don't know. So this is a hypotenuse. So adjacent side will be the side next to my angle, which is this one. Opposite side is the side opposite to my angle, which is this one. Okay. So what is sine theta? Sine theta is opposite by hypotenuse. Okay. Now what will cos theta be? Adjacent by hypotenuse. And tan theta will be opposite by adjacent. Okay, this is small memory aid that you can use to remember. You can just remember it as SOH, which is sine opposite hypotenuse. Sine is opposite by hypotenuse. CAH, cos is adjacent by hypotenuse, and tan is opposite by adjacent. So, toa. Yeah. For some of you, this might be more difficult to remember, no? Yeah. So it's always good if you can make your own shortcuts. There are certain things that you will remember. So you can relate to that and make shortcuts for your studies. Okay, that will help you, do things. Now, let's say I don't want to find out this angle. Okay, but I need to find out this angle. Now everything will change. Now which is my opposite side? Which is my adjacent side? Hypotenuse won't change. But this is going to be my adjacent side. The side next to the angle is always adjacent side. And this is going to be my opposite side. Okay? I have my adjacent side. I have my opposite side. Now what will my sine theta be? Again opposite side by hypotenuse, but this time I have to take this side. Do you understand the difference? Yeah? Okay. So hypotenuse, adjacent side, opposite side. Adjacent side and opposite side is determined by whichever angle you're taking. Okay. So what all did we discuss here? First thing we discussed was quadratic equations. How to solve them? You can split them. So you can split them. Or you can use the minus b plus or minus 4ac, that formula. Then directions. We looked at the directions. Very important. South, north, east, west. When you're doing displacement distance questions, this is very important. Then what did we look at? We looked at work. Looks like I'm writing French, no? Just a second, students. Yeah. We looked at work. We looked at energy. We looked at power. And then we looked at scalar quantities, vector quantities. What else did we look at? We looked at distance, displacement, speed, velocity. Another thing that I can tell you here is about velocity. Okay. So imagine there's a running track, a circular track. Okay. And you're running from here and you come back to the starting line. What will your total velocity be? Quickly. In 1 second, tell me the answer. Yes. For all those who answered 0, well and good. Very good. Why is it 0? What is velocity? Displacement by time. So what is the displacement of this person? It's the shortest distance, which means he is at the starting point itself. After the whole race, he came back to its initial position. So his displacement is 0. 0 by t is 0. So velocity is 0. Speed will be the speed by which he ran the whole track. Okay? That's one way of looking at it. Another way of looking at it is, you can say, velocity is something that changes with direction. So if you cut a circle into two, they're the same in opposite direction. So if he is running in this way, he's going to run in the opposite way in the opposite circle, opposite part of the circle. So here if he goes this way, here he is going to go this way. So the velocities cancel out because they're going to be in two different directions. So in total, in the circle, all of the velocities together will cancel out. So that is why in a circle, total velocity is always equal to 0. Okay? Yes. what else? Yeah. So, very important thing that you need to know your tables. 1 to 25, squares, cubes. Okay? All these three things you should learn. And then everything we discussed. So here are some basics for your 11th grade that can give you a small quick push start. Okay? So I will be coming with more videos on more basics and more content and whatever you ask. So if you need videos on any specific topic or anything, you can just let me know in the comments. Okay? So let me know in the comments. Also, I put some questions in between. I want you to answer them and put those answers also in the comments. I will be liking your comments. Okay? So thank you so much for your time and all the best for your future. Okay? So keep subscribe to our channel. Like this video if you found this interesting. Like, share it to all your friends who are still struggling to, get that quick start in 12th. Okay? Please do subscribe to our channel so that we can give you the best possible content. Okay? Bye-bye students. Love you all. Thank you.